Hello all. Today's class is on food additives and food pigments. So let's go to it. So what are food additives? So food additives are substances that are added to products to perform specific functions. These functions include preservation, that is increasing shelf life or inhibiting the growth of microorganisms, adding color, enhancing flavor, etc. So there are over 300 permitted additives that can be used in different countries. Okay, so there are different types of food additives. So the definition, you can see that it is a substance or a mixture of substance other than the basic foodstuff which is present in a food as a result of any aspect of production, processing, storage, or packaging. So it does not include contaminants. Okay. So according to the Food and Drug Administration, the term food additives refers to any substance that the intended use of which results or may reasonably be expected to result directly or indirectly in its becoming a component or otherwise affecting the characteristics of any food. So it means that it is something which can be used in any of the like in terms in the time of production, processing, treatment, packaging, transportation, or storage of food. So it is something added to the food. So there are, sometimes what happens is the type of food additives can be classified as first is intentional food additives and incidental food additives. So intentional is something that is added intentionally to improve the product quality and sensory properties. They are like we carefully control the conditions and you're adding something to it. And in some, the permissible amount, for example, preservatives, antioxidants, emulsifying agents, stabilizers, flavoring, coloring, etc. And unintentional or incidental additives are those which are not deliberately added, but they gain entry. Sometimes in the time of production, sometimes at the time of storage, processing, or even marketing. Like marketing means like when you're packaging it, sometimes what happens is some plastic can get inside your food, etc. So they find their way into the food accidentally. Sometimes like during the production, maybe pesticide residues may be present in your fruits or vegetables. Then toxic metals can be there, anti-nutritional factors can be there, heavy metals can be there, or even packaging food, or any dust particles, microorganisms, or even rod, I mean any insect can also be there. So these are additions to foods, but they are not intentional. That is why it is called unintentional food additives, or in other words, contaminants. Here we're going to discuss only about intentional food additives. Okay. So food additives classified can also be classified based on the source from where it is obtained. So those classification is natural, completely from natural sources, like it can be from animals, plants, microorganisms, but it is totally from natural sources. And synthetic is something completely which is prepared in a laboratory in a chemical, fully completely chemically synthesized. Then nature identical, it is the source is actually from it is made taken from natural sources, but there are some modifications are made to it, and that is why it is called as nature identical. Okay, so let's see what are the functions of food additives. The first one is preservation functions, like enhance the shelf life of foods. We know that preservatives are added so that some foods are not getting spoiled really fast. That improves and maintains the nutritive value of foods. Some certain vitamin, we can see that certain foods have been fortified with vitamins, any mineral, etc. Like iodized salt is an example. That reduce the wastage and improve yield of the product. Like sometimes what happens is sometimes to prolong the way the the life of the foods, it can so that wastage is reduced. Then facilitates the processing or preparation of food, like we have anti-caking agents or leavening agents, etc. Improves color and appearance of food. Of course, our natural and artificial coloring agents can be used. Then improves body and texture of food, like when you're making bread and all, you add yeast to it, so there's improve the body and texture of food. Then improves aroma and taste of food. Certain things like our MSGs can increase the taste of the foods, enhance the consumer's acceptability of the food. Of course, when you're increasing these good additives are added to it, naturally consumers will have more acceptability to the food. So there are a lot of positive sides to it, because a lot of problems are there. Like there are big chances of food spoilage, especially this is today's global world. One food is being transported to different parts of the world. We are not local consumers. So what happens is you need to add certain things so that the shelf life is improved, so that the food does not get spoiled, and you need to properly package it, process it, etc., so that when you are processing it or when you're packaging it, naturally a lot of lot of additives come into play. What are the different types of food additives? There are different types of food additives are there, like colors, flavors, emulsifiers, gelling agents, preservatives, so on. So we'll discuss some of them. So first one is colors. So colors is like provide, preserve, or enhance the color of any product. So it's the easiest one. So it enhances the color. So we have seen a lot of foods which are colored, like you can see our laddu and jalebi. All of those are colored, and a lot of sweets. So many processed foods. Most of the processed foods we have seen that mostly, some amount of color is added. What are the different colors that can be added, like annatto, carotene, cochineal, chlorophyll? Some of them are natural, some can also be artificial. So synthetic colors are there. So we'll be discussing about colors in detail later on. Now, foods in which we use a lot of different foods, like confectionery, cake, sweet, savory, fruit syrup, different juices, etc. So sometimes the maximum permitted limit is like 200 mg per kg. Okay, that is the amount of color which is permitted. The next one is flavor enhancers. Now, flavor enhancers is improve the flavor or the aroma of the food, so that the food is, smelling really good and tasting really good. Now, one of the most famous or the most commonly used flavor enhancer is monosodium glutamate. It's also called as Ajinomoto. So, up to 1% can be used. Then yeast is also another flavor enhancer. It gives a particular taste to it. Now, also, different masalas, Chinese cookery, these MSGs are used, noodles and different types of foods. These flavor enhancers are used. Now, next one is flavoring agents. Like, they also give a particular taste to foods. Like flavoring agents means they are different from flavor enhancers. Now, flavor enhancer is something that enhances something which is already there, like when you're adding these MSG to this Ajinomoto to our food, it just increases the taste and flavor. It does not add a particular taste of its own, but it just increases the taste. That is, it just enhances the taste or flavor which is already present. Now, flavoring agent is something different, as in like you're inducing something. For example, a chewing gum. There are different types of chewing gum which are lollipops or chewing gums which are available, like vanilla flavor, banana flavor. So what are those? So chewing a gum which is induced with a particular flavor. So it can be natural extracts, synthetic flavor chemicals. They are like aldehydes, ketones, ester, etc. So different, like in our 7-Up and all, it's just soda, right? Water and soda and sugar, but some flavoring is added. That is why you get that particular taste of 7-Up or Sprite or Coca-Cola, etc., because they add certain flavoring agents to it. The next one is emulsifier. Now, emulsifier is very important. This is something like the most commonly used. You can see that is when you're preparing mayonnaise. Like mayonnaise is, it is an emulsion made from oil, and sometimes oil and eggs. When you combine oil and eggs, what happens is that like after some time there is a chance that these oil and the oil gets separated out. So separates out. That is like there is a different layer is formed. Now, because it's not unevenly distributed. Okay. But when you are adding an emulsifier, it actually increases the, it makes it very smooth and even. So different types of emulsifiers are used, like lecithin. Soy lecithin is a very common emulsifier which is used in different chocolates, ice creams, cheese, etc. There are also like ammonium phosphatides, etc. So there are different emulsifiers which actually makes it like a smooth, smooth appearance to the foods or emulsions. Then antimicrobial agents are anything that prevents the growth of microorganisms, bacteria. So all our preservatives are coming under this category. We have like benzoic acid, chlorobenzoic acid, salicylic acid, so sodium benzoate, sorbic acid, presence in squashes, jams, crushes, etc. They use a lot of antimicrobial agents. Then curing and pickling agents. Now this curing and pickling agents will have a particular, they add a particular flavor, and also like characteristic like pickles and all, there is a particular flavor to it, and also you get increase the shelf life. For example, pickling agent, you can see a very common one is vinegar. Then salt can be used for pickling. Then in the case of meat and all, sodium nitrite. So sodium nitrite is used in the preservation of meat. So this is also, the sodium nitrite gets converted to nitric oxide, which combines with the myoglobin, which is present in the meat, to form nitric oxide myoglobin, which inhibits the growth of Clostridium and Streptococcus bacteria. So that is like curing and pickling agent. So this is used in, enhancing the shelf life of these foods. Then maintaining appearance and palatability, wholesomeness. So sometimes what happens is certain things are, to increase their appearance, certain, so that they appear the completely whole. Certain foods, additives like propionic acid, calcium and sodium salts, or propionic acid, ascorbic acid. Then butylated, you must have seen in certain foods like BHA is present, that is butylated hydroxyanisole can be used. Certain syrups, fruit juices, frozen dried fruits, etc. These are used. Then next one is anti-caking or free flowing agents. Like this is very commonly seen in salt, like iodized salt. You can see if it is the non-processed salts. If you see, like for example, salt is made from seawater, right? Like by distillation, seawater is heated and you get the salt. But you see that it is very moist. The natural salt is very moist, which kind of sticks to each other. But when you add an anti-caking agent to it, it is a free flowing. That is, it doesn't stick to each other. It's not moist, etc. And you can easily pour it from any container. So that is like it prevents lumping and caking. That is why anti-caking agents are used. They're mainly used in table salts and all other powdery materials. What are the certain anti-caking agents? Is carbonates and phosphate of calcium. Like calcium carbonate is used, calcium phosphate, phosphates is used, silicate is used, etc. So these are things which helps in free flowing of certain powders. Then antioxidants. Now, antioxidant is something which prevents oxidation. Like oxidation, for example, like you must have seen that in coconut oil, etc. Like when you like oils or certain foods which are kept in the open, there is a process that happens, that is oxidation. That is, it reacts with the atmospheric oxygen and it gives a very particular flavor or change in the color. So what happens is, for example, we know that apple, when it is cut and kept outside, what happens is it gets brown, right? So this is something like oxidation happens. So to prevent oxidation, you need to add certain things called as antioxidants, so that it prevents the flavor and color changes and retard rancidity. So there are different antioxidants present. Vitamin C is a very good antioxidant. Then vitamin E or tocopherol, citric acid, tartaric acid, propyl, galates. Then BHA is also another, that is butylated hydroxyanisole, is also a good antioxidant. So in a lot of things, antioxidants are used in oils, fats, different dry mixes, because these things get when exposed to air, gets oxidated. Then sweeteners. Sweeteners are another group of additives where you're actually increasing the sweetness of any product without increasing the calories. This is especially good for all the diabetic patients out there, because diabetes is mainly you can't eat sweets, because not the sweet taste that is the problem, but it is the carbohydrate or the caloric content, the carbohydrates or the glucose which is the problem here. So that is why sweets are but the sweet taste itself is not a villain. So these non-nutritive sweeteners are used because it provides less than 2% of the caloric value of sucrose per equal. Like that sucrose is sugar, table sugar. So that is why table sugar or sucrose contains some amount of calories which are which gets converted to glucose, and that increases the sugar levels, right? So there are different non-nutritive sweeteners like aspartame, acesulfame, etc. Now they are used in different, soft drinks like you have Diet Coke or Diet Pepsi and all, in which these non-nutritive sweeteners are used. That sweeteners can also be nutritive. That is they get really small amount of calories, like sorbitol, which is from natural sources. Sorbitol, the polyols, etc., which are also used in certain chocolates, ice creams, etc. Then there are certain other food additives like enzymes, which are used for digestion of certain foods like meat, like cheese, etc. They use for making cheese, enzymes are used. Rennet enzyme is used for making cheese. Then tenderizing meat, like for example, peptane is an enzyme found in papaya. Okay, it helps in tenderizing meat. For example, like when you are cooking meat and all, you can add a little amount of raw papaya so that it tenderizes meat, because this enzyme peptine is present in it. Then next one is new neutralizing agents. So that neutralizing, the name itself says that to decrease the amount of acid. So alkaline salts like sodium carbonate, etc., are used so that they decrease the acidity. They are used in wines, ice creams, etc. The next one is stabilizing agent. This is also helps in ensuring a stable emulsion, or it can be also sold as thickener, like in the case of ice creams, form stabilizer in beer, chocolate, in chocolates and all. These stable emulsifiers are used, which helps in what do you say, increase helping that the emulsion is stable. The different examples are Carrageen gums, gum arabica, etc. That firming agent is something which helps so that the texture is maintained. For example, mainly used in canned vegetables like canned tomatoes, canned pineapple, etc. Because sometimes what happens in when you are canning foods like tomato, which is present, maybe it can be it can be canned in salt water. What happens is tomato, after some time, what happens, it becomes very withered, it becomes very it loses all its texture. But these calcium carbonate, sodium, aluminum, phosphate, sulfate, etc., can be added so that the canned tomato will be, it stays as a tomato. It won't, just dissolve or anything like that. So that is a firming agent. Then humectants. So sometimes what happens is, you have seen Bounty chocolate, right? It is in that shredded coconut is it is included inside the chocolate. So what happens after some time, like when it is kept in the open and all, this coconut and all, it becomes really dry. So to prevent undesirable drying of foods, to maintain the moisture level, humectants are added. What are the different types of humectants? Glycerine, sorbitol, mannitol, dextrose, corn syrup, etc., are added. And this is an example. Shredded coconut is being added with humectant so that it does not get dried up. The next one is sequestrant. Now, sequestrant is something, for example, sometimes in certain foods, what happens is there can be different, free metallic ions, which can lead to discoloration, changes in their flavor, oxidation, turbidity formation, etc. So what happens is these free metallic ions are, they are bound to certain these sequestering agents or chelating agents, which actually binds with all these unwanted metallic ions which are present in the foods. Okay, like calcium, EDTA, phosphates, the organic acids like tartaric acid, citric acid, etc., which helps in removing those unwanted metal ions, because chelating agents will chelate or will bind with these things. So this is mostly used in soft drinks, malted beverages, etc. Now the next type of food additive is flour improvers. Now flour means we have seen like the wheat flour, maida, or refined wheat flour, etc. So flour improvers means mainly the texture, and when you want to what is flour used for? Mainly for bread, baking, then all other chapatis, all those things we use flour, right? So we need flour improvers are making enhance the properties of the dough, and also to convert protein so that the gluten is improved, so that you get very good baked products. What are the different types of things used? It is like potassium bromate, calcium oxide, then benzoyl peroxide, etc. are used, and also for bleaching also, like the flour, when you see like especially the refined wheat flour and all, it looks very white, right? Now you're using a lot of bleaching agents, and also that the color is also improved. And also the dough is when you prepare the dough with it, it is very good. That is, it helps in you can easily knead the dough, etc. So these things are used for improving the quality of the dough. The next one is aerating agents like soft drinks. That is naturally all those, soda is added, like carbon dioxide is added. So soda is, for example, when you want to make a like soda with the soda maker, what you do is you add these aerating agents and gases like carbon dioxide, CO3, calcium carbonate, etc. With because to generate gas, mostly for alcoholic beverages and soft drinks. All your 7-Up, Pepsi, Coca-Cola, all these have aerating agents in them. The next one is solvents. Like sometimes what happens is certain flavors or certain things need, they are not soluble in water. So you need certain other, they will be not, for example, when you're extracting vanilla. Now, vanilla is a flavor, right? So it is extracted from the vanilla plant. Now, vanilla plant, what happens is it's not soluble in water. What you need to have, so when you want that flavoring, you've seen this vanilla in bottles, etc., right? So you need to have a solvent in which this extract can be dissolved. So that is different types of solvents can be used, like oils can be used, ethyl alcohol can be used, propylene glycol can be used. So these are the things which act as vehicles which carry these things. Okay, that is why it is called as vehicles. Then next one is leavening agents. Now leavening agents is as simple as like increasing the fluffiness of any product. For example, our bread or cakes, etc. Naturally, when you add baking powder or baking soda to it, naturally it gets puffed up. The increase in volume is there, so that it becomes very spongy, light, fluffy, etc. So this is used in all the baked products like bread, biscuits, etc. So you need, our baking powder, baking soda, etc. are examples of leavening agents. So you can see there are differences, like when there are no additives, naturally there will be no leavening, and when there is an additive and a leavening agent is added, naturally you get a fluffier, a spongier product. Now, another thing is clouding agents. Now, clouding agents is increasing the haze, or you can see in this picture over there, something like to increase the thickness. Like for example, like you want to make a gravy which is very thick. Sometimes when it is like very watery, you want something to have a thickness of it. So calcium phosphate, cellulose derivatives, gums, starches, or corn flour, when you add corn flour to our gravies and etc., so it becomes really thick, right? So if it is like if you are making some if you have made some vegetable curry, and that's very watery, doesn't look good, naturally you add some corn flour or cornstarch to it, it becomes very thick and it gets clouded. So that is why clouding agents are used. Next one is clarifying agents. Now clarifying agent is the opposite of clouding agent. It is to remove cloudiness. For example, in the case of beer, wine, fruit juices, etc., all these packaged fruit juices, they contain these clarifying agents, because it should be very clear, there should not be any clouding. So tannic acid, gelatin, etc. are used so that it is clear. Then nutritive additives. Now that is like, so all those, when you are making any food, when you're processing foods and all, what happens is there are chances that the certain nutrients are lost during the processing. So to make up for that, or to otherwise itself to increase the nutritive value of any food products, nutrition or certain nutrients are added, like vitamins can be added, minerals can be added. You can see a lot of foods nowadays are like fortified with iron, fortified with calcium, etc., because you need to improve the nutritional quality of the foods, like milk, salt, like iodized salt, wheat flour can be, there are vitamin D is increased, etc. So these are called as nutritive additives. So these are the different types of additives which are commonly used in foods. So let's see, how do you identify labels, especially in the case of processed foods? How do you know that labels? Actually, by law, it is important that these additives are mentioned in your label. So you must have seen a lot of numbers, like E numbers. No, all the it started in the Europe. There is all the food ingredients, direct additives. It is required by law that it is listed on the package label by their common names in the order of the weight. That is, whatever is present in the highest number should be kept first in the label. For example, if there is like a lot of color is added, then that should be added first, then the thickening agent, the emulsifier, etc., like that. So the European Union countries have drawn a list of 314 safe food additives, and each of them is given an E number. Now E is for Europe, that is because it started in the European country. So E is it is controlled by the EU, the European Union. Now the first digit, so there is a 3-digit number will be there, like E102. Now the first digit tells us the additive is a colorings, because different first digit, for example 100 to 199 is colors. Okay, 200 to 299 is preservatives. So you can see that different types of additives have different E numbers. Then E300 to E399 is antioxidants and acidity regulators. E400 to E499 is thickeners, stabilizers, emulsifiers. Then 500 to 599 is pH regulators and anti-caking agents. 600 to 699 are flavor enhancers. 700 to 799 includes antibiotics. 900 to 999 is miscellaneous, and all the other additional chemicals come under 1100 to 1599. Okay, so these are the different E numbers which are giving the different type of product, I mean different additives. So it is an like for example, you can see E100 is an example of curcumin or turmeric is given the E number as E100. Then E123 is amaranth. Then E140 is chlorophyll. E210 is benzoic acid. Now, benzoic acid is a preservative, right? Even potassium metabisulfite is a preservative. That is why it is starting with 2. So that is what is the different types of E numbers which are given. So these are all this has been adopted. It was started in the European Union, but now it has, it is universal. That is why it is, adopted by the Codex Alimentarius Commission, and it is universal. All the countries will, specify these numbers, because, you should not use any common names, but instead you should use this E numbers in your labels, so that it is common all over the world. So you can see this is the different types of this thing. There is like antioxidants are starting with 300. Then emulsifiers, it can be 3 or 4. Like lecithin is an example of emulsifier which is used in ice creams, etc. Then acids like citric acid is used. It starts with E500, like sodium hydrogen carbonate, E500. Then sweeteners like E420. Nutrients actually not numbered, because they are completely they are used to increase the nutritive value. Because of that, nutrients are not numbered, but instead they are mentioned in the package, like it is vitamin C, fortified, etc. So there are another very important topic is safety aspects of food additives. Now, sometimes food additives, like especially preservatives and all, if it is used in like large amount, naturally it is not good for your health, because it is a chemical and it can lead to a lot of problems. So how do you know what is the acceptable intake? So for each of those additives, there is something called as the acceptable daily intake, or ADI. It is the amount that can be consumed on a daily basis for a lifetime without much risk. So it is measured in unit as mg per kg body weight per day. So for each of these food additives, like for example, like for all the preservatives, for all the colors, etc., there will be something called as the acceptable daily intake, which is called as ADI. Okay. Now there is another term which you need to know is GRAS. GRAS substances mean generally regarded as safe. So these are like, for example, salt, sugar, etc. are GRAS, additives, because they are, there is like something which is, introduced by the US Food and Drug Administration, because, to give endorsement to those substances which were used for many years and which does not have any evidence for harmful effects. That is why they are called as generally regarded as safe, or GRAS. Now, this question as what is GRAS was once asked in the NET exam. So please make note of all this, the terms, etc. Now there is another like studies related to colors, etc. Like increasing the different synthetic colors which are used. It has been linked with attention deficit, like hyperactivity, etc. Certain colors which are used in if it is increased in amount, like children who use who eat a lot of candies which are colored. There is a chances that they suffer from hyperactivity. There are a lot of studies which also prove that. There are also a lot of other things which are related to preservatives, increased preservatives, which can cause a lot of problems like cancer, tumors, etc. So there are different types of studies. So that is why this acceptable daily intake must be taken into consideration when you are consuming all these additives. Now let's move on to the next part, that is pigments. So pigment is something which imparts color to the foods. Now naturally, we look at something and like whenever we eat foods or etc., we think we we give a lot of importance to the color, right? Like how your curry should look like, how apple should look like, how any of the food we have our picture of a food is mainly the color of the foods. So pigments are something which imparts those colors. So pigment occurs in many forms like liquids, powder, gel, paste, etc. Can be like natural pigments and synthetic pigments. Synthetic pigments are all the things that we have, coloring agents we have mentioned earlier, all the chemical things which are produced. Now, natural pigments are something we're going to study. Like, for example, the most common natural pigment is chlorophyll, which is the green colored water insoluble pigment, which is involved in photosynthesis, which is present in all the green leafy vegetables. So all those, the green color in all plant foods are for chlorophyll. Now, there are two types of chlorophyll, that is chlorophyll A and chlorophyll B. Now, chlorophyll A is something that is intense blue-green color. So, intense color is chlorophyll A, and chlorophyll B is this intense yellow-green color. For example, you can see in this picture, like yellow-green is when they are, especially during after it has aged, the leaves and all, after it has aged, it becomes a yellow-green color. So, that is when the chlorophyll A starts decreasing and chlorophyll B starts increasing. Now, what is the effect of cooking? Now, when green vegetables are put in boiling water, what happens is sometimes the color becomes bright, initially. And after prolonged cooking, what happens is the color changes from bright green to an olive green. That is, it becomes dull. But what happens is, when alkali is added, like sodium bicarbonate or baking soda is added to your cooked foods or cooked green vegetables, happens is the color is retained, or this becomes bright because of something called as a water soluble chlorophyllin is formed. Okay, because it reacts with chlorophyll, the phytyl and methyl groups are displaced and a bright green water soluble chlorophyllin is formed. But what happens is the original chlorophyll is actually water insoluble. Now, the best main ways to retain the green leafy green color of the green leafy vegetable is to freeze it, so that especially when you are blanching it before freezing, it's best to retain the color. Now, the next pigment is carotenoid. Now, this is also another water insoluble pigments like yellow, orange color of all the fruits and vegetables, like they are extracted from annatto, saffron, paprika, etc. Now, some examples of carotenoids which are present in foods are like yellow corn, which contains cryptozanthine, which is a carotenoid. Lycopene is an example of carotenoid which are present in tomatoes. Beta carotene, xanthophylls are present in carrots, pumpkin, etc. Then red capsicum contains beta carotene. Then in plants, carotenoids are present as alpha carotene, beta carotene, gamma carotene, xanthophyll, and cryptozanthine. So among all the carotenoids, beta carotene is the most important for, especially for the synthesis of vitamin A. So they are not much affected by acid, alkali, and amount of water, because you see that in carrots, even when you are making curries out of carrot, not much of a color change is there. It is water insoluble also, so it doesn't leach away the color, because it doesn't make much of a difference to the color of the foods. Next one is anthocyanin. So they are red, blue, and violet water soluble compounds. Okay, which are occur in some fruits and vegetables like blueberry, red grapes, pomegranate, etc. Now they are contained in the vacuole of the plant cells, and that is why they are easily dispersing easily with the water. So sometimes when you are cooking it in water, the what happens is for example, when you are cooking grapes for making juice, etc., what happens is the color is entirely leached onto that liquid, right? Like when you are boiling the grapes in water, what happens is the entire water becomes that color of the grapes because it is water soluble. Then skin of radish, sweet potato, cabbage, etc., are all due to the presence of anthocyanin. Now, sometimes when you add an alkali like sodium bicarbonate, it gives a bluish green shade to this anthocyanin pigments. So when sometimes when you are adding iron or aluminium, tin, etc., can change the change of this anthocyanin pigments can be from green to blue. Next one is anthoxanthin. Now these are like creamy yellow, creamy white, yellowy white. For example, our garlic, cauliflower, potato, etc. This is also water soluble components. So they are colorless or white depending on the pH. Now they are generally white in acid medium like in lime juice and all. When you add these things, it becomes white, and it becomes yellow in an alkaline medium like sodium bicarbonate, etc. The examples of anthocyanin is cauliflower, potato, cabbage, garlic, etc. All those white foods can see that is contains anthocyanin. Next one is betalain. Now they are like certain times what happens is anthocyanin is replaced by beta-cyanin, beta-xanthin, which are commonly known as betalain. So betalain are water soluble again, which is present in mainly beetroot. So this acid, when you add acid to it, increase the red color, and alkaline pH, it brings out brownish blue shades. They are also, permitted additives. So betalain is present in beetroots. Next one is saffron, turmeric. All those are natural colors. Turmeric, that it gives a very good yellow color to all the foods items like making curries, etc. Then saffron is used for making that, a particular golden color. So that lot of, it gives a very rich color. Then lot of it is also used as a coloring agent. Then synthetic colors are all those colors which are manufactured in chemical reactions. Like synthetic dye stuffs, etc., are used. The benefit of synthetic color is that it is extremely bright. It is more stable. There is no problem. And if it is like heat is added, alkali is added, acid is added, it's not a problem because it is very stable, and it's very cheap also because a bulk quantity can be produced. Unlike like when your saffron and all is extremely expensive, right? But in the case of synthetic colors, naturally it's very cheap. But the problem is it has a lot of health problems because there are chances that it can be toxic, especially if it is above the ADI or acceptable daily limits. Now, what are the different permitted synthetic colors are there for producing like red, poncho, carmosin, fast red, amaranth, erythrocin? All these are the common names for uh, the synthetic colors which give the red color red. Then yellow is given by tartrazine, sunset yellow. Then blue is by indigo carmine. These are all the names of the different synthetic colors. Okay. Green is given by fast green, green CF. So all these colors will have a particular E number also. Because as we have discussed earlier, these are, it might not be, when you might not see it in their original names, but can be given as E numbers. Okay. So these are the different food additives and food colors.